friends, today we will discuss signal flow graph and block diagram reduction through signal flow graph. So at first, what do you mean by signal flow graph? Actually, signal flow graph is a pictorial representation of algebraic equation, and it is a way to solve the algebraic equation. So a block diagram is generally a block diagram. A system is a differential equation, and that differential equation is at first converted in algebraic equation, or you can say that is splitted into algebraic equation, and then that algebraic equation is represented as signal flow graph, and then we determine the transfer function by the use of signal flow graph. We use Mason-Gain formula, the formula given by Mason to determine the the transfer function of a signal flow graph. The Mason-Gain formula says that the transfer function is given by sigma pi delta I divided by delta, where pi is nothing but they are the forward paths, delta is the and delta is I will explain later on what is pi, what is delta I, and what is delta. So actually signal flow graph has nothing to do with any other things. It is only meant for finding out the transfer function of a system. It doesn't have to do anything with stability. It doesn't have to do anything with the with finding the response of system. It only finds the transfer function of a system. So let us come on the question. During the question we will explain how to find the transfer function. One by one we shall see the previous year questions asked in GATE. So now the first problem is signal flow graph is used to obtain the stability of the system, transfer function of the system, controllability of a system, observability of a system, and this question has been asked in GATE 1993. So I have just now I have told the signal flow graph is nothing to do with the controllability, observability, and the type of response, the stability of a system. It only determines the transfer function of a system. It only reduces the blocks and determines the transfer function of the system. So which option will be correct? So option number B is the correct one. Now we are on the second problem of signal flow graph. So it says that the overall transfer function of the system in figure is, this is the overall, so this is the figure given of the system, and the question is asking about the transfer function of the system, and this question has been asked in GATE 1992. So how we can solve? Let us see. At first we should denote the different points by its name. So suppose this is a summing point. Let us take its name as A. Okay, let us take this point as A. Again, let us take this point as this is a takeoff point. So let us take this point as B. Okay, let us take this point as C. This is also a summing point. This point as C. Okay, now let us take, this is again a takeoff point, you can say, because, so let us take this point as D. Okay, let us take this summing point, the name of this summing point as E. Okay, so now we can draw the signal flow graph. So let us draw the signal flow graph. So how many points are there? W, A, B, C, Y, D, E. So 1, 2, 3, 4, 5, 6, 7. So there are 7 points. Okay. So let us draw the signal flow graph. So signal flow graph is given by signal flow graph is given by suppose this is point W. Okay, this is point A. Okay, let me write this point as also, this point as also some F. Let us write this point as F. So this point as F. So this point is F. Now this point is F and this point is W. This point is W. Okay. Now it is okay. So now this point is E. This point is A. Okay. This point is E. Okay. Now this point, here a point is B. This point is B. Here a point is D. This point is D. And here a point is, that point is C. Okay. And here a point is Y. Now let us join all the points as it is joined in figure. So W is joined with F. So I have already joined W by F. Okay, this is F. Again F is joined with A. So let us make a straight line to join. Okay, F. Again F is joined by E. Again this A is joined by B through block G. So A is joined by B. Okay. Again E is joined by D. So let us join E by D. So now we have to join B by E. So let us join this B by E. Again A is joined by D. So again A is joined by E. So again B is joined by C. So this B is joined by C. And D is joined by C. And this C is joined by Y. So now our block diagram, our signal flow graph is complete. Now we have to show the path gains of each path. Signal flow graph is complete, and now we have to denote its path gain only. So what is the path gain? From W to F, the path gain is nothing. That means 1. The path gain is 1. Let us denote it by red. From F to E, again path gain is 1. From F to A, the path gain is again 1. Okay. And from A to B, the path gain is G, because it is passing through a block G. So from A to B, the path gain is G. So let us denote it by G. Okay. From B to C, again the path gain is 1. Okay. From F to E, the path gain is 1. I have already denoted it. Again from E to D, the path gain is again G. From E to D, the path gain is again G. And let us denote here. Here we should denote the arrow like this. Okay, the arrow should be in this direction. So from D to C, again the path gain is 1. Okay, from D to A, the path gain is, from D to A, the path gain is H. And again from B to E, the path gain is, B to E, the path gain is H. Okay. and from C to Y the path gain is 1. C to Y. So now our signal flow graph is complete. So now we have to make use of Mason gain formula to find the transfer function of this block diagram. So what Mason gain formula says, let us say again what Mason gain formula says. So the transfer function of a system will be here input is W and output is Y. So the transfer function, let me write Mason's gain formula. What is Mason's gain formula? Then we will Mason's gain formula. So it says that the transfer function. Ts is given by is nothing but sigma pi delta I divided by delta. Now pi denote pi is where pi is the path gain of ith forward path. Okay, forward path means any path which is connecting from input to output. Suppose we have to see here in this signal flow graph which one is a forward path. So it is, we can easily see, we say that W, F, A, B, C, Y. This is a forward path. From point W to Y, we can reach Y following this path. So this is a forward path. Similarly, this is again a forward path. So now I think it is clear to all of you what is forward path. So Pi is the path gain of forward path. So path gain, what will be the path gain? So path gain will be the path gain of forward path will be multiplication of the path gain of all the branches which are lying in that forward path. Suppose we are calculating the path gain of forward path W, F, A, B, C, Y. Then it will be 1 multiplied by 1 multiplied by G multiplied by 1 multiplied by 1. Since these all branches are lying in that path, or you can say these all branches constitute that forward path. So and now it is clear to all of you that what is the path gain of forward path. So here Pi is the path gain of ith forward path. And now what is delta? So delta is nothing but delta is calculated as delta equal to 1 minus sum of loop gains of individual loops plus sum of gain products of two non-touching loops. Sum of gain products of all two non-touching loops. All two non-touching loops. Let me write this side because it will be in the use. All two non-touching loops. Okay, like that, minus sum of gain product of all three non-touching loops, like that. Okay, so it will be continued till it will satisfy. After that we will do plus sum of gain product of four non-touching loops, like that. And this is delta. And what is delta I? So delta I is calculated for path pi. So what is the difference between delta and delta I? So delta I is nothing but it is also delta, but it is for those loops only which are not touching the path, the ith path. So delta I is delta for those loops delta is delta for those loops which are non-touching the ith forward path. The ith forward path. Now I think it is clear to all of you what is Mason gain formula. Now let me find out the transfer function. So let me wipe out the Mason's gain formula, then we will write here what will be the transfer function for this problem. Construct the signal flow graph. Now let us see what are the forward paths and what are the loops here. So here we should write forward path, forward paths. Here path gain, and here delta associated with that forward path. Delta associated with forward path. Okay. Now let us see what are the forward paths. So the first forward path is WFA BCY. Let us denote its path gain by P1. So P1 will be nothing but 1 multiplied by G multiplied by again 1 multiplied by 1. So it will be nothing but G. What is the second forward path? The second forward path is WFEDCY. WFEDCY. And what will be the forward path? Path gain for this path? Let us denote it by P2. So it will be again 1 multiplied by 1 multiplied by G multiplied by 1 multiplied by 1. So it will be again G. So what is the let us see whether any more paths exist or not. So WFABEDCY. Yes, there is one more. There is some more forward paths. So WFABEDCY. Now let us denote its path gain as P3. So what will be P3? So P3 will be nothing but 1 multiplied by 1 multiplied by G multiplied by again H multiplied by G multiplied by 1 multiplied by again 1. So what will be it? It will be G square H. Okay. Let us see whether any more forward paths exist or not. So A B E D C Y. I have written. Now W F E B A W F E B W F E D A B C Y. So W F E D A B C Y. This is the fourth forward path, and let us denote its for path given as P4. So what will be the P4? So the value of P4 will be, again we can see it will be 1 multiplied by, again this 1 multiplied by this will be G multiplied by here 1 more will again come 1 multiplied by 1 multiplied by G multiplied by again H multiplied by G, this G multiplied by again 1 multiplied by again 1, so it will be G square S. So there are 4 forward paths. Now there is no possibility of any more forward path. So now let us see what are the loops for this signal flow graph. So let us write here loops. What are the loops? And here let us write loop gain. Loop gain. Okay. So E D H B E. There is one loop E. There is one loop E D A B E. And what will be its loop one? Let us denote it by L1. So L1 will be nothing but G multiplied by H. This is H multiplied by again G multiplied by H. So it will be G square H square. Let us see whether any more loop exists or not. So there is no possibility of any more loop. So there is only one loop in this system. So now we can see that all the 4 forward path touches this loop, or we can say that this loop touches all the 4 forward paths. So delta for these forward paths will be, let us denote for forward path 1 delta 1, so it will be 1. Again delta 2 will be again 1. Delta 3 will be again 1, and delta 4 will be again 1. All the delta for forward path will be 1, because since there is only one loop and that loop is touching all the forward path, we cannot find any such loop which is non-touching these forward paths. Okay. Now let us calculate the delta. So delta is nothing but 1 minus L1, because here since there is only one loop, so 1 minus L1. So it will be 1 minus G square H square. Now by use of Mason's chain formula, let us try to find out the transfer function. So the transfer function will be transfer function Ts equal to, what will be it? Sigma Pi delta I divided by delta. So G multiplied by 1 plus G multiplied by 1 plus here G square H multiplied by 1 plus G square H multiplied by 1 divided by 1 minus g square h square. Let us write this side. Let us write this side. So it will be, now ts will be 2g plus 2g square h divided by 1 minus g square h square. So if we take 2g common in numerator, then it will be 1 plus gh, and in denominator it will be 1 minus gh multiplied by 1 plus gh. So 1 minus 1 plus gh will cancel out each other. So we are left with only 2g by 1 minus gh. So which option is correct? So option number, this is option number B. This is option number B. So option number B is correct one. So now option number B is correct one. Question is, the signal flow graph for a system is given below. The transfer function ys divided by us for this system is. This is the signal flow graph given, and there are 4 alternatives given, and this question has been asked in GATE 2013. So let us see which one of the given alternatives are correct. So the signal flow graph is, let me name out the points in the signal flow graph. So let this point be A, okay, this point be A, this point be B, okay, let this point be C. Now it's okay. So now let us try to find out the transfer function. So how many forward paths are there? So first forward path is u, a, b, c, y, okay. Second is u, a, b, c. Again here we have to give some name so that it would be clear. Let me give here a name D also. So D, and here path gain, here the path gain will be 1, because 1 multiplied by 1 will be again 1. So D, U, A, B, D, C, Y, okay. This is the second forward path. Let me see, is there any more forward path? So there, it seems that there is no more forward path. So let us write here what are the forward paths. So the forward paths, let us write here path gains, and let us write here delta associated with path. Okay. Now here there are we have identified 2 forward paths. So let us write one first forward path as U, A, B, C, Y. Let us denote the let us denote the path gain of this forward path by P1. So P1 will be nothing but 1 multiplied by, again, x to the power minus 1 multiplied by x to the power minus 1, okay, multiplied by 1. So it will be nothing but x to the power minus 2. Again, the second forward path will be U, A, B, D, C, Y. Now the path gain will be, the path gain for this path will be P2 equal to 1 multiplied by x to the power minus 1 multiplied by this 1 multiplied by this one, okay, multiplied by this one. So it will be nothing but x to the power minus 2. Let us find out the loops. So what are the loops in this signal flow graph? So loops here, let us write here loops, here loop gain, okay, Now the first loop is B D C B. B D C B. This is the first loop. Second loop will be B D C A B. Okay. Is there any more loop? Yes. C A B C. So let us write the loops. What are the loops? So first loop will be B D C B D C and B. So let us write its loop gain as L1. So L1 will be equal to nothing but 1 multiplied by s to the power 1 multiplied by minus 4. Okay, 1 multiplied by minus 4. So it will be minus 4. B D C B. Okay. So second loop will be B D C A B. B D C A B. And let us write the loop gain as L2. So here it will be 1 multiplied by minus 2 multiplied by s to the power minus 1. Okay, so it will be minus 2 s to the power minus 1. The third loop will be, what will be the third loop? So third loop will be here C A B C. Okay, so loop gain for this loop will be minus 2 multiplied by s to the power minus 1 multiplied by again s to the power minus 1. So it will be minus 2 s to the power minus 2. Let me check whether any more loop exists or not. So one loop is this one. One loop is this one is one loop. Okay. This one is another loop. Yes. This one is another loop. B C B. Okay. So another loop is B C B. So another loop is, so fourth loop is B C B. B C B. Okay. B C B. So the loop gain will be, what will be the loop gain? So the loop gain will be s to the power minus 1 multiplied by minus 4. So it will be minus 4 s to the power minus 1. Let us check whether any more loop are existing or not. So this one is another loop, and this one is another loop, this one is another loop. No. So there are only 4 loops. All these loops are having BC part in common, and the 2 forward paths are also having B and C as common. So all these 4 loops are touching the 2 forward paths. So delta associated with these 2 forward paths will be nothing but 1 only. So let us denote the delta associated with path 1 as delta 1. So delta 1 will be 1 and delta 2 will also be 1. Again, what will be the delta? The delta equal to 1 minus L1 plus L2 plus L3 plus L4. Okay. Let us see whether the 2 loop are non-touch. No, because all loop are passing through C. Here C, here C, here C, here C, here C. So all loop are touching each other. So there exists no 2 such loop which is non-touching to each other. So 1 minus L1 plus L2 plus L3 plus L4 will be delta. So we can write delta as 1 plus, this will be, let me write 1 minus 4 minus 2 s to the power minus 1 minus 2 s to the power minus 2 minus 4 s to the power minus 1. So it will be nothing but 5 plus 6 s to the power minus 1 plus 2 s to the power minus 2. Okay. Now the transfer function will be, so now we have to apply the Mason's gain formula for finding the transfer function. So the transfer function will be Ts equal to nothing but sigma pi delta I divided by delta. So it will be, what are p? So s to the power minus 2 multiplied by 1 plus s to the power minus 1 multiplied by 1 divided by 5 plus 6 s to the power minus 1 plus 2 s to the power minus 2. Now if we multiply both the sides, both the numerator and denominator by s to the power minus 2, then it will come like 1 plus s divided by, it will come like 2 plus 6s plus 5s square. Okay. Now let me see which one of the following given options are correct. So 1 plus s, okay, 1 plus s are in A, B and C, divided by 2 plus 6s plus 5s square. 2 plus 6s plus 5s plus, this is not 5s square, 2 plus 6s plus 5s square. Okay, so option number A is the correct one. The next problem is, for the block diagram shown in figure, the transfer function is equal to, this is the block diagram given, and this problem has been asked in GATE 2004. There are 4 alternatives given, so let us try to find out the transfer function. So let us find, at first let us find the what will be the signal flow graph. We can find it by signal flow graph or otherwise also. So let us find the signal flow graph first. What will be the signal flow graph? Okay, so actually RS is here, RS is coming to here also, and RS is coming to here also. So let us at first let us make the points, let us denote the points on the given diagram. So let us denote this point as point number A. Okay, this point as point number B. This is summing point. This point as point number C dash, because C is here, so let us denote it as C dash. Now let us denote this point as also, this point as D, or we can leave it, we cannot, there is no need to denote this point, or we can denote it as D. Let us denote it as D. Okay. So now let us make the signal flow graph. So signal flow graph will be, signal flow graph will be as, how it will be? So there will be 5 points, R, A, B, C dash, C and D, 6 points. So here let us make R, here A, so this is R, this is A, this is B, okay, this is C dash, and this is C. Okay, and now there is one more point D. So from R to A, from A to D, and it is going to be, so there is no need of D also, because we can directly uh, uh, join R with B, R with this B. We can directly join R with B. Okay, this is B, and we can directly join R with C dash also. So R with this C dash also. So I think there is no need of this point D. So okay, now from A to B we have to join between A to B. Okay, now from B to C dash, now we have to join between B to C dash. Okay, now between C to C dash, this will come, this is completing our it is connected from these two branches should be connected from A. So let us meet it with A. So it will be like this. It will be like this, and it will be like this. Now it is okay. Since it is connected with A, so let us make it connected with A. Now let us denote the path gains. So between R and A, there is a unity path gain will be there. Between A and B, the path gain is 1 by S. Okay. Between A and B, there is one more path. Between A and B, there is one more path, and that path is having its path gain as 1. Between A and C dash, there is one more path. There is one path having path gain 1. So between A and C dash. Now between C dash and C, between B and C dash, it is having path gain 1 by S, and between C dash and C, it is having path gain 1. Okay. Now let us denote this point as something. Suppose here we denote this point as D, or here we denote this point as D. Okay. Now we have denoted this point as D. Now if we denote this point as D, then what will be the path gain from A to D? It will be again 1, because total path gain should be 1, and since it is from D to B, I have denoted it as 1, so it should also be 1. So total path gain from A to B is 1. Okay. Now it is okay. Now our signal flow graph is complete. So now let us see what are the forward paths. So forward path between between R and C. So let us write here forward path. Here path gain. Here delta associated with path. Delta associated with path. Now the first path is R. The first path is R A B C dash C. R A B C dash C. And let us denote the path gain for this path as P1. So P1 will be nothing but 1 multiplied by 1 by S multiplied by 1 by S multiplied by 1. So it will be 1 by S square. Okay. The second path will be, what will be the second path? The second path will be R A D B C dash C. R A, this is A, R A D, B, C dash, C. This point is C dash. Okay. So let us denote its path gain as P2. So what will be it? 1 multiplied by this one multiplied by this one multiplied by 1 by s multiplied by 1. So it will be 1 by s. The third path will be R A C dash C. R A C dash C. So what will be the path gain for this third path? Let it be P3. So P3 will be 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by again 1. So it will be 1. Let us check whether any more paths exist or not. So one path is this one, another path is this one, okay, another path is this one, and there is no other paths. And what are the loops? Is there any loop or not? So this one is not making any loop, this one is also not making any loop. So there is no loop. So there is no loop. Here we should write loops. Here under the heading of loops we should write there is no loop. There is no loop. There is no loop. Okay. So delta associated with these paths will be only 1. So delta 1 will be 1, delta 2 will be also 1, and delta 3 will be also 1. And what is delta? Since delta is, since there is no path, no loop, since there is no loop, so delta will also be 1. Because, or you can say since no loop exists, there is no loop. Since there is no loop, there is no loop. Okay. Now the transfer function will be, what will be the transfer function? The transfer function will be by Masonian formula sigma pi delta I divided by delta. So how much it will be? So it will be 1 by s square plus 1 by s plus 1 divided by 1. So how much it will be? So we will get s square plus s plus 1 divided by s square. Okay. So which of the given options are correct? So option number B is correct one. Okay. Option number B is. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.